in this question, you have seen the section of a cylinder. The section is passing through a point which is 40 mm above the base, and the angle is 45 degree. Angle is 45 degree. Fair enough? Yes or no? And what I have done in this, all the intersecting points, I have named it as 1. This is having 2 intersecting points because B and H is there, so 2, 3. C and G is there, 4 and 5. F and D is there, 6 and 7. And here I have made it the intersecting at the top as 8 and 9 because we have 2 intersecting points. Comfortable? Is this clear? Now, after the section, you have to understand this particular portion is removed and this particular portion is kept. You should remember, for a cylinder, there is no edges. There is no edges. So we need not to dark this particular surface because for a cylinder, this is a clear-cut drawing. Now, let us see how we'll go for the development of this particular solid. Now, when you open this cylinder, what will you do? What will be the length? It is 2 pi r or pi d. What is the diameter? Pi cross 50. It shall come around 157 mm. So what I want to say is the length will be the circumference. Length will be the circumference. So 15.7 centimeter will be the length of the rectangle. And what will be the height? The height shall be 60. Height shall be 60. When I open this cylinder, any confusion to it? Any problem to it? No, right? So I will draw a cylinder of 157. I'll draw a cylinder of 157 by 60. 157 by 60. This is 60 and this is 157. Any problem with this? What I have done is I have opened the cylinder wherein I have got a rectangle of 60 by 157. Any confusion? Any confusion? Yes or no?
No, sir.
No, sir.
Let us go ahead. Let us go ahead. Now, I have divided the cylinder in 8 equal parts. If you can see, I have divided the surface of the circle, like, the top base or the bottom base, whatever you can say, into 8 equal parts. So I'll take the distance of those. I'll take the distance of arc, because what I have done is this surface is nothing but I have opened this thing, right? I've opened this thing. So let us call this as A, and this is also A. Because when you open this, when you join again, these two surfaces will be coinciding. These two surfaces will be coinciding. So I have started with A and ended with A. So, and then I have taken the distance of each arc, that is somewhere with the compass. So I will mark each arc like this at A and A. So let us call B, C, D, E, F, G, and H. If you see A, B, C, D, E, F, G, H, A. Again, similarly, A, B, C, D, E, F, G, H, A. Comfortable? Hayana?
Yes, sir.
Now I will take.
Yes, sir.
I will draw construction lines. I will draw construction lines. Properly draw the construction line. Now, when you draw the construction line, take roller scale so that this will be parallel. This will be parallel See that these lines are parallel to the A line, or else perpendicular to A line. Fair enough. I have drawn all the construction lines. Now, let us see from point A, this, how will we mark it here? We have to mark all 1, 2, 3, 4, 5, 6, 7, 8, 9 points. So let us draw the points with the help of the compass. From A, this was A, right? This is A dash, right? This point is A dash, right? Ayana? Yes or no?
Yes, sir.
So from point A dash, what is the distance of 1? This is 1. I have taken the distance with the compass. So I have marked it from. Similarly, this A is also same. I have marked it here. And I will name it as 1. I will name it as 1. Similarly, from B to 2 and 3, I'll take the distance from B to 2, and again H to 3 is same distance. This distance is same. So B to 2 I'll mark, H to 3 I'll mark. Whenever you mark it, write the name then and there. Similarly, from C and G, I will mark 4 and 5. Similarly, C4, G5. This is 4 and this is 5. Similarly, F and D is 6 and 7. So D, say for example, is 6 and this is 7. Now you have 8 and 9. Now you have 8 and 9, which is at the top part of the solid. How to see the length? Now, can you tell me this E and F length arc is nothing but this arc? Similarly, because it is EF, this is EF, so this is EF again. The top part of EF is here and top part of D is here. So if I take from E this 8 distance towards F, E 8 distance towards F, I will take E here and mark here. This is, for example, 8, and from E again towards D, I will mark 9. And from E, I will mark it here as 9. Now, when you have all these points, always remember, when you are cutting a cylinder, when you cut a cylinder, you cut a cylinder like this, your surface will be a curve. But when you cut a solid like cube, you will be having edges like this. When you cut, the cut section will be like this. Accepted? Because this has edges, flat surface. This has round surface. This is a round surface. So my cut part, I will be joining not with straight line, but a curve like this. 9 and 8 has to be joined with straight line because it is a straight line. It is cut. There is a cut portion, and then so this is when you join 1A with this 1A, you will get the portion which is left out after this particular portion is cut through. So this is nothing but your development. When you draw the development part, try to mark this as dark, the leftover portion to be dark. So this is nothing but your DLS. DLS stands for development of lateral surface. So you can dark this particular portion. This has not to be darkened because these are the drawing edges, but cylinder has no edges. I will be taking next question as a cube. I'll make you understand there. Okay. So this is what your now when you will be understand. Let us check with this answer. How will you check this answer? Let us see which particular portion is left out. This portion is left out. This is removed. This portion is removed. Now let us see. A1 is dark. Mine A1 is also dark. 1, 2, 3 has to be darkened because this portion will be left. 1, 2, 1, 3 is dark. 3, 2, 3, 4, 5. 2, 3, 4, 2, 4, 3, 5 is dark. 4, 6 and 5, 7 is dark. 4, 5, 6, 7. This particular portion is dark. So like this, you have to check. Now, when you join this, you will get the solid, right? Yes or no? Ayana.
Yes, sir.
Very good. So that is what is expected from you. So this is nothing but your development of lateral surface. Now let us take, this was question number, this was which question number? Question number 3. This is question number 3. Let us take another interesting question. Question number 10. Let us take question number 10. We'll solve question number 10. You can see this page, right? Ayana. Question number 10. Let us draw question number 10. Can somebody read it for me? Question number 10. All are. Do you have the question bank? You have the question bank, yes or no? Yes, he has that. So Prajwal writes, so let us, I will also read that question. Now, in question number 10, it is said that a cube of 40 mm side edges resting on one of its face has its vertical faces equally inclined to VP. So let us understand what do you mean by equal inclination to VP. First, the first thing I'll do is, first, I'll understand equal inclination to VP. Now, this I have drawn for my XY. This I have drawn for my XY. Now, if you see, if I keep this solid here like this, can I say this surface and this surface, these two surfaces are equally inclined to vertical plane? Ayana?
Yes, sir.
This surface is making 45 degree to vertical plane. This surface is also making 45 degree to vertical plane. So they are saying that the cube, which is 40 mm, is having its vertical faces equally inclined to VP. It is cut by a section plane perpendicular to VP such that the true shape of the section is a regular hexagon. Draw the front view of the cut solid, the sectional top view and the true shape, and also draw the development. Let us draw the top view. What will be the top view of a cube? Cube का top view क्या होगा? It will be a square. Now they are saying it will be equally inclined. So you take a construction line, and I will also take another construction line, and I will draw two lines which is 45 degree to each other to make it equally inclined. So I will take 4 centimeter line. I will draw 4 centimeter line here, and again 4 centimeter line here. Similarly, I'll draw another 4 centimeter line which is perpendicular, and then another 4 centimeter line. So thereafter, if you can see now, can you say that this, say for example, let us call it as A, B, C, D. Can you tell me AD side and DC side is equally inclined to vertical plane? Can I say that? Yes or no?
Yes, sir.
Because this is 45, because this is 45 degree and this is also 45 degree. Fair enough. Let us draw its front view. How will you draw the front view? You take all the then take 40 as its height, because the height is 40. It's a cube. This edge you will be seeing. Join it. This also you will be seeing. So this is nothing but my A dash. This will be my B dash, D dash. This will be my C dash. Accepted? Now, are you convinced of this particular edge as dark in front view? If you are not convinced, see like this. See like this. This edge you can see in the front view, right? Yes or no? So it is in
Yes,
this
sir.
condition. It is in this condition, and these two surfaces are in apparent position, because when you see from here, this black surface, you are not able to see the true shape. This yellow surface also, you are not able to see the true shape. You will be seeing the apparent, and this edge is also dark because it is visible. Ayana, yes or no?
Yes, sir.
Yes, sir.
So can we go
Yes,
ahead?
sir.
Can we go ahead? Now they are saying it is cut by a plane perpendicular. मतलब perpendicular मतलब तलवार चलाना. Perpendicular to vertical plane. Perpendicular to vertical. Yesterday I have discussed section में when it's perpendicular to the vertical plane, we call it as talwar. When you cut, like when you cut by perpendicular to the horizontal plane, you cut through like an axe. Axe is cutting like a wood axe, right? Okay. Now it is saying that it is cut through somewhere like that कि उसका section is a regular hexagon. Hexagon is having how many sides? 6 sides.
6.
ठीक है? So how will you cut so that your section will be a hexagon, regular, that too regular hexagon? So let us consider, we will see that it goes from the half of the top and this half of the bottom. I will cut in such a way that it cuts like this. So for example, this is my cutting section, and see that it is going in half of it. Now when you take the projector down, this is my nothing but my section. You have to see that from D to C midpoint it is going, and also from B to C midpoint it is going. Okay? You have to check and then draw. This is my now current section. You can make this two line light, because this will not be there when you will be having the solid. little lighter you can make, right? And this also you can make it light because it will not be there. Okay? Now, let us define these points. Now, let us define these points. Let us say AD, this point as 1, 2, 3, and 4 intersecting points. Say, for example, this is 1 and 2, and this is 3 and 4. Okay? And this we call it as, for example, 5 and 6. Okay? Now, how to see the true shape? How will you see the true shape? When you see this particular here as right angle, perpendicular, so you will be seeing the true shape. So I will draw a parallel line with the section. I'll draw the parallel line with the section and call it as x dash y dash, and then take all the points, all the projectors should be perpendicular to xy, all the points like this. I have taken all the intersecting point, and now take the distance. When the projector is given by the top, front view, distances will be given by the top view. Now, since it is above xy, so you will be taking the distances, like all the projector 1 and 2, I will take 1 here, mark it. I will take the distance from x and y 2, mark it. Similarly, I'll take the distance of D, say for example, whatever you can call D or 5 and 6. It's up to you, no problem. 5 and 6. I'll take the distance of B. Similarly, 4 above XY, and then 3 above XY. Now you join this with straight line. You join this with straight line. Now you can see we have got a regular hexagon in our true shape. So our objective is done. We have achieved our objective to get a regular hexagon. How did we get a regular hexagon? We have nothing but cut in proportionate with the front view. I will tell you again, we have cut in proportionate. We have taken the midpoint of this line and midpoint of this particular from top and bottom, and we have joined it, and we have seen the intersecting point is A and D ka midpoint, A and B ka midpoint, again B and C ka midpoint, D and C ka midpoint. Correct? So this is nothing but 1, 2. This is, you can call it, it's up to you. You can call it as 5 and 6. So this is 6 and 5. This is, we can call it as 4 and 3. This is nothing but your true shape. Write down very clearly. And this is nothing but your sectional, because you have done the sectional part. Section matlab ye hatching you have done, so it's a sectional top view. This is front view. Okay, did you understand this? Yes or no? So can we go ahead with the development of this? Let us see how to develop this solid. Now, what is the development of this? What we need to do is we have to open this cube. When you open the cube, what will be the perimeter of it? What will be the perimeter? Perimeter will be nothing but 16. Perimeter will be nothing but 16, because 40 mm into 4 parts, right? 40 mm into 4 parts. So I will just draw here 16 mm for you. It should be visible for you. That's why 16 mm, one line. I'll draw a rectangle of 16 by 4. I'll draw a rectangle of 16 by 4. 16 by 4. And join it. Here, when you cut, I was telling you the edges will be defined. So this will be 4, this will be 8, this will be 12. So you draw first very light lines. Draw first very light lines. Now, if you see, there are from the top view, if you see A, B, C, D, A, B, C, D. So here it will be A, B, C, D, and again A, because this will be joining and making the solid. Now let us see how to take the points. Now, where is 1 and 2? Where is 1 and 2? At the top position. So I will take the distance of A to 1 from D. I will take the distance from A to 1, and it is in between A to D. I will mark here is A to D at the top, because this intersection is in the top of the solid. Similarly, I will mark A to 2, where it is, it is in A to B, right? A to B. And where is the intersection? It is at the top of the solid. So I will mark from A to 2. Let us name it. This is A to D. This is 1. And A to B, this is 2. Similarly, from B dash to D dash, since it is not top, it is at the above xy. So I will take the distance. It has cut throughout. I will take the distance from B dash to D dash. I'll take the distance from B dash to D dash. I will cut from B1 point again D1 point, because I have called it as 6 and 5. Because D ka point I have called it as 6, and B ka point I have called it as 5, the intersecting point. Similarly, 3 and 4, it is cut at the base of the solid. It has cut in the base of the solid. So I'll take from D to 4, and C, B to C ka length, that is, C to D ka length, which is at 4, I will cut here. I'll repeat, I have taken from D to 4 distance, and I have cut from D to C ka line mein 4, and call it as this is 4. Similarly, from B to 3, I will take the distance. I'll take the distance from B to 3, and in the line of B to C, I will cut here. This is 3. So I have jotted down all the points. Now I will show you how, when you open this after the section of this particular solid, when you open this, how will be your development look like? You will darken the lines which is left out. I'll tell you, you have to dark like this. All the edges 2 to 5 you will join with straight lines, because it is it has the surface. It is having the surface. The cylinder was not having the cylinder was having a curved surface. Cube is having a flat surface. Similarly, this line, this portion, you will make it dark. Now, guys, you have to understand one thing. When you join this, somewhere you'll get this particular portion. Let us now understand we have done correct or not. A to this line, is it dark? Will it be dark after your cut section? Yes. So my lines are dark. My A line is dark. This line is also dark. Let us see. Say for example, this is for your understanding. This is R point. R2 1 and 2. R2 1 and 2. Is it dark? R2 2 is dark. R2 1 is also dark. Now let us see. A dash to B dash and D dash has to be dark. A to B is dark. A to D is dark. This is just for your verification. When you do 2-3 questions, you will be able to understand. Now this triangle B D dash 5 6 3 4. This triangle will be there inside the solid after being cut. So it has to be dark. So you can see B53 and D64 is there and it is dark. So this is just for your verification. So this is nothing but your DLS, wherein you have to denote this length. This length is nothing but your 160, because 40 cross 4 perimeter, that is 160 mm, and this length is nothing but your 40 mm. So this is nothing but your development of the solid when it is being cut like this. I hope you have understood it. Yes or no? So this is how we draw the development of a solid. So in this, if you see, if you join this and then wrap it, you will be finding this particular portion after being cut, after the section is cut. So this is the sectional top view. This is the true shape of the section. This is the front view, which is the left out portion, and this is the development of the cube which is given.